Hello. It looks like the other skill that we need to go over is making sure we know how to solve radical equations. So it says solve the equation and check for extraneous solutions. Again, I'm going to go ahead and cut this in half. All right, and we're going to go ahead and get started. Okay, so there's a couple different steps I gave you guys for solving radical equations. If you see two radicals, right, which radical is like the square root sign or any root, really, you need to get them on both sides of the equation. So I'm going to go ahead and add 2 root x to both sides, which means I'm going to actually take up the whole space here. So that means I got x plus 27 equals 2 root x. All right, next we need to go ahead and get rid of these square roots by squaring both sides. All right, so the square and the square root cancel itself out, so you're left with x plus 27 on the left. This is where you have to be a little bit careful on the right. Sorry, that is my phone. Very unprofessional. Who is texting me? Miss McConnell, that jerk. Okay, where were we? Oh yeah, okay. Yeah, so we have to be careful because here on the left, everything's under the square root, so you're just left with what's under it. But here, not everything's under the square root, so that makes a difference. So this becomes 2 squared, which we know is 4. Again, that's not 2 times, well, in this case it is, but it's 2 to the power of 2, okay? Like if that was a 3, it would not be 6, it would be 9, okay? And then that just cancels itself out. So you're left with x plus 27 equals 4x. Wow, this one turned out super nice for you guys. Subtract x, that should be in green. Oops. Subtract x from both sides. This is like a linear equation. You know how to solve it. 27 equals 3x. Divide both sides by 3. And x equals 9. But you can't circle it yet because you have to check. I'm telling you guys right now, if you don't check your answers, I'm not going to give you an A. Like, you have to check it, whether it's extraneous or not. Okay? If it's not extraneous, but you didn't check it, I'm still not going to give you an A. Like, you have to check it. Anyway, so this becomes 9 plus 27 under the square root. Does that equal negative 2 root 9? Let's go ahead and check it. 9, 18, 27, square root of 36. Does that equal negative? Oh, that shouldn't be like that. It should be minus 2 root 9. Does that equal 0? Sorry. Get rid of that. So does that equal minus 2 times 3? Does that equal 0? That becomes 6 minus 6, which equals 0. Yes. So this one, it does work. So your answer is x equals 9. Sweet. So that one we're good. Hopefully you guys kind of followed my check. You should know how to check at this point, though. So anyway. All right. The next one is the square root of x plus 11 equals x minus 1. Okay. So hopefully your first instinct is to try to get rid of that square root, which means I need to square both sides of the equation, which means here I have x plus 11, again, because the square root and the square root cancel themselves out. Here you have to be careful. I'm going to do some scratch work on the side. This is x minus 1 times x minus 1. Okay, a lot of you guys are going to be tempted just to put that 2, like square everything, but you're going to miss out on some stuff. X times x is x squared. That becomes a minus 1x minus another x, so that's a minus 2x, and then negative 1 times negative 1 is plus 1. Okay, so that's x squared minus 2x plus 1. Okay, you've got to be careful with that. So if you miss that, you're going to do everything else incorrectly. Now, hopefully your next instinct is, hey, that's a quadratic equation. Let's set it equal to 0. I'm going to subtract x and 11 at the same time because I am a complete daredevil. 0 equals x squared minus 3x minus 10. Okay. I wonder if this will always factor. I'm looking at this, and I know, because I am a brilliant math student, that this actually factors. The factors of 10, that would combine to 3. There's 1 and 10, 2 and 5, and that's kind of it. If everyone could stop. I am so popular today. It's crazy. Anyway, I know that this factors is x minus 5 times x plus 2. All right, which means I can now use zero product property and that will tell me that either x minus 5 equals 0 or x plus 2 equals 0. Okay, and then I can solve both of those. Add 5, x equals 5, or subtract 2, x equals 2. Okay, the problem is you got to check your answers. Okay, I will say at this point you have options. A lot of you probably would have used quadratic formula. You can also complete the square, although you wouldn't want to in this case because that's an odd number, which means you would end up completing the square with decimals or fractions. So a lot of you guys are probably going to do quadratic formula, which is fine, but this is also a good chance for you to practice your factoring. Anyway, we need to check our answer. Okay, I'm going to do my check over here. I really don't want to do my check right there though. Oh, everything's going off screen at this point. It's okay. I'm going to do my check down here. You guys will hopefully, you'll see most of that. All right, so check. I'm going to check my x equals 5 first. Again, you should always check in the original equation. So does 5 plus 11, does that actually equal 5 minus 1? So that becomes 16 under the square root. Does that equal 4? Well, yes, it does. So x equals 5 is a correct answer. All right, now we need to check. I'm going to do this check in red. X equals 2. The square root of 2 plus 11. Does that equal x minus 1, which is 2 minus 1? That becomes the square root of 13. Does that equal 1? No. That means that is extraneous. Okay, so that's why I left you guys a box for your final answers. X equals 5 goes in here. That is extraneous. All right, didn't actually work out. But there you have it. Go back to the original problem so you guys can see what I was substituting in. Yep, that is how you solve radical equations. There's a ton of other radical equations I could have given you guys. These only have square roots in it, which is actually kind of really nice of me. So you're welcome. Okay, bye.